Okay, in this lecture we're going to finish our section 3.2 material on trigonometric integrals. So the last type of integral that we'll talk about in this section would be integrals that involve products of functions of the form sine of ax, sine of bx, cosine of ax, and cosine of bx. So there are some integrals that we might need to evaluate products of sine or cosine of x, but where the arguments of these functions are different values. Say, for instance, the product of sine ax and sine bx, where a and b are different numbers, or sine of ax with cosine of ax. How could we handle something like that? Or sine of ax with cosine of bx, where those arguments are different. So in order to evaluate integrals of products of these types of functions, we're going to be making use of the following three trigonometric identities. So the first one says if we're taking a product of sine and cosine of different arguments, that is sine of a and cosine of b, where a and b are different numbers, we can express this as 1/2 of sine of the difference, a minus b, plus sine of the sum, a plus b. Now, if we're considering a product of two sine functions of different arguments, let's say sine of a times sine of b, where a and b are different numbers, we could express this as 1/2 of cosine of the difference, a minus b, minus cosine of the sum, a plus b. Or, in the third case, let's suppose that we're taking a product of cosine functions that have different arguments, say cosine of a and cosine of b, where a and b are different values. Well, we could express this as 1/2 of cosine a minus b plus cosine of a plus b. All right. So let's consider some examples illustrating each of these approaches. So in our next example, we're asked to evaluate each integral. And in part A, we're looking at the product of sine of 4x and cosine of 5x. So this is a trig integral, but since sine and cosine have different arguments, in particular 4x and 5x, we can't use the approaches that we had considered earlier involving products of sine and cosine of the same argument. So instead, we have to make use of a trig identity. Here, since we're taking the product of a sine and a cosine function of different arguments, we're going to make use of this first identity. So let's rewrite this as the integral of 1/2 of sine of a minus b. So here a was the argument of our sine function, so we're going to have 4x, and then we're subtracting b, which was the argument of our cosine function, 5x, plus sine of the sum of a and b. So that is 4x plus 5x. So by making use of that first trig identity, we could rewrite our integrand in this way. So let's see what we have. I'm going to pull the constant of 1/2 out in front of my integral, and I'm left with the integral of sine of negative x plus sine of 9x dx. Now I can integrate each of these terms directly, or if I want to make the notation a little bit simpler, I might use the fact that sine of x is an odd function. So in other words, sine of negative x is the same as negative sine of x. And then I still have my plus sine of 9x term. So evaluating this antiderivative, I have 1/2 of the antiderivative of negative sine x is cosine x. And then the antiderivative of sine of 9x would be minus 1/9 cosine of 9x. And at this stage, after I've evaluated my integral, I want to include a constant of integration to get the most general antiderivative. Now if I want, I could distribute this factor of 1/2. So I would have 1/2 cosine of x minus 1/18 cosine of 9x plus c. All right. So let's look at some other ones. In part B, we have the integral of sine of 5x times sine of 2x. So again, I'm taking a product of two sine functions. However, the argument of these two sine functions is different. So in order to evaluate this integral, we're going to make use of one of the trig identities we had discussed earlier. So we could rewrite this as the integral of 1/2 of, if I'm taking the product of two sine functions, say sine A and sine B, I would have a cosine of A minus B. So here, 5x minus 2x, minus cosine of A plus B. So that is 5x plus 2x dx. So by making use of that trig identity, let's see what we have. So pulling the constant 1/2 out in front of the integral, I'm left with the integral of cosine of 3x minus cosine of 7x dx. And here I can evaluate directly. I have 1/2 of the antiderivative of cosine 3x would be 1/3 sine of 3x. And then minus the antiderivative of cosine 7x is 1/7 sine of 7x. And then I'm adding a constant on the end since this is an indefinite integral. Or distributing my factor of 1/2 that was out in front, I would have a 1/6 sine of 3x minus 1/14 sine of 7x plus c. All right. Now in our last example, we have the integral of a product of two cosine functions of differing arguments, cosine of 3x and cosine of 4x. So again, making use of a trig identity for a product of two cosine functions, we could rewrite this integrand as 1/2 of cosine of a minus b, so here 3x minus 4x, plus cosine of the sum 3x plus 4x dx. So factoring out the constant 1/2 in front of the integral, we have half the integral of cosine of negative x plus cosine of 7x dx. So here I could evaluate directly, or to make my work a little bit easier, I could make use of the fact that cosine of x is an even function. So that is cosine of negative x is the same as cosine of positive x. Plus, I have my cosine of 7x dx. So we have here a 1/2 of the integral of cosine x, which would be sine x, plus the integral of cosine 7x, which would be 1/7 sine of 7x, plus c. Or again, distributing the constant 1/2, I could rewrite this as 1/2 sine x plus 1/14 sine of 7x plus c.